Hey everyone, welcome back. I'm Daryl, and this is part two of my web server project for the HD extension. As covered in part one, I have built a single-threaded web server, but today we're taking everything I built and making it significantly more capable. Let's get into it. So just a quick recap of where we left off. In part one, I have built a web server in Python. It listened for connections on a port, received an HTTP request from a browser, found the file on a disk, and sent it back either with a 200 OK if the file existed, or a 404 if it does not. The whole thing worked, and it worked pretty well as well, but it had one significant limitation. It can only handle one request at a time. And that's exactly the problem we're trying to solve today. So back to the restaurant analogy, think about a restaurant with only one waiter. The waiter takes your order, walks to the kitchen, waits for the food, and brings it back to you. And while all of that is happening, every other customer just has to sit there. Nobody gets served until your order is completely finished. And that is the single-threaded server. It works, but the moment a second person knocks on the door while the server is busy, they'll have to wait for their food. In the real world, Netflix, Google, or any other site are handling simultaneously thousands and thousands of requests. And so how do we get from one waiter to a full team of waiters? The answer to that is multi-threading. Instead of one person having to do everything, we have a manager and a team of workers. The manager stands at the door and greets every new customers, and the moment someone walks in, the manager hands them off to a dedicated worker or a new thread in this case, who handles that customer from start to finish. The manager doesn't wait around. They go straight back to the door, ready for the next person. Or in technical terms, every time a new TCP connection comes in, my server spins up a new thread just for that specific connection. Each thread runs completely independently, so multiple requests are processed at exactly the same time. So here's exactly what it looks like in practice. First and foremost, the main thread is running in a continuous loop of accepts. The moment it accepts a connection, it creates a new thread and passes that connections into it. Immediately after that, it goes back to listening. Each thread then calls the handle client function, and that's where all the actual work happens. It then reads the request, finds the file, sends the response, closes the connection, and then the thread disappears. So let me walk you through two parts of the code that make multi-threading works. First and foremost, it's the main loop. Every time this loop runs, it calls the server socket.accept function. That's the line that just sits and waits until a new connection comes in. The moment one does, it immediately creates a thread object, passing it two things: the handle client function it should run and the connection socket to it. Then the t.start function, and the thread is off and independently running. So the main loop doesn't wait for you. It goes straight back to the accept function, ready for the next connection. The second part is the handle client, the worker function that each thread runs on. On the left is the happy function or the correct path, on the left is the happy path or the correct path where the thread reads the incoming HTTP request, strips the slash from the file name, opens the file, reads it, then sends back a 200 OK header followed by the file content itself. On the right is what happens when a file doesn't exist. Python's open function throws an IO error instead of crashing. We catch it in the accept block and sends back a 404 response with a simple HTML error page. Crucially, only that one thread is affected. The actual server itself will keep on running unaffected while the other threads keep doing their jobs. So let's get right into the demo. First things first, we'll go ahead and run two tests, the browser test and the client test. We'll do the browser test first. We'll do this by first running our server. This is our multi-threaded server itself. Here's the code for it. So we'll do this by pressing the run and debug button and wait to see for the ready to serve text. Once it shows, it means that the server is ready to go. So first I'll open up my existing web page. In this case, I'll put in my port number followed by colon. Sorry, I'll put in my IP address followed by a colon, followed by the port number, and the existing file. Here we go, load it up properly. So now let's try to do this with a non-existing file. We'll do that for hello-darryl.html, 404 not found. Okay, so that's our browser test working properly. And here is our client script itself. This is the script we're going to be using to test the multi-threaded server. Okay, we do this by putting in this command line. So it's python3 client.py, our IP address, our port number, followed by the file. So we'll run this, and it runs it pretty good. It returns to us the HTML. Now let's try doing this to a non-existing file. So instead of hello world, let's put in a random file name, say hello Daryl again. Okay, and it returns to us a 404 not found page instead of the server crashing. So to wrap it up, I have built a multi-threaded TCP web server in Python that handles multiple connections simultaneously. This is done while serving real HTML files, returning proper HTTP response, and was tested with both the browser and a custom command line HTTP client. At its core, a web server accepts a connection, handling it to a worker, and sending back a file. Every website you've ever visited is doing something that looks a lot like this under the hood, just at a much bigger scale. Again, my name is Daryl, and thank you so much for watching.